Okay, number one is looking at a linear function. So an empty backpack weighs 1.2 pounds. This should read backpack. A backpack with 6 books weighs 22.5 pounds. Assume that each book weighs the same. So, letter A, does the weight of the backpack W and the number of books B represent a direct variation? So direct variation means that it's a type of linear function, so we know it's a constant rate of change, that passes through the origin. So if you look at this situation, it's not going to pass through the origin because you could make an ordered pair of 0 books and 1.2 pounds. So if you had 0 and 1.2, that has a y-intercept of 1.2, so it's not direct variation. Write a function to model this, so a linear function. So I can set up 2 points. I know that at 0 books, it weighs 1.2 pounds, and then at 6 books, it weighs 22.5 pounds. So then what I can do is I need to find the slope. So I did change in y over change in x, 22.5 minus 1.2 over 6 minus 0, and my slope is 3.55. So then I wrote that into point slope form, which is right here. So this is my linear model. And you could solve for y and put it in slope intercept form too, but I just did it this way. And then letter C, you're going to use your linear model to figure out the weight of the backpack, which is y, and plug in A for x, because x represents the number of books. And you get 29.6 pounds, and make sure you write in units. And then number 2, make sure you know how to use linear regression on your calculator, and also to tell whether something's a linear model. So if it looks like it's a linear model, it means it's making a line or similar to it. And then just a couple other notes. Hundredths means 2 decimals if you had to write it to the nearest thousandths. Don't forget that that's 3 decimals. And tenths is 1 decimal to round it. And then predict what y would be if x is 12. So you just got to pay attention whether or not you're trying to solve for y or x. So in this case, we're going to replace x with 12 using our equation. Okay, now we're getting to 3.6 absolute value. So write a function y equals the absolute value of x. This is the parent function. And then you shift it up 2. So we're adding 2. And we're going left 3. So remember, when the general form, was a times x minus h plus k. So h and k, we're shifting it or translating it. So when you translate something, you're just shifting it either up, left, right, down, combination. So h is the opposite of h. So if it's going left, that's why it's plus 3. And the a not only tells you whether it's a reflection across the x-axis. So remember, if this number is negative, it's the parent function's like this, at the origin. And then if it's negative, it's reflected. And the a also tells you whether it's a stretch vertically. So that's when the absolute value is greater than 1. Or it's a shrink vertically. So the absolute value is between 1 and 0. So a shrink vertically would look like this or like this. It's wider. And a stretch would be narrower. So let's look up here. Number 4, write a function for y equals x after it has been reflected across the x-axis. So we know the a is going to be negative. Shifted down 2, that's why it's minus 2. It has a vertical shrink of 1/4. So that's 1/4 is the a. And then number 5, describe the transformation of this function. So transformations, remember in geometry, changing the figure. So transformation could be a reflection, a stretch, a translation. So we're going left 1 because it's x plus 1, and up 2 because there's a plus 2, and we're stretching it vertically. It's not a shrink, and it's going across x-axis because that's a negative. And down here is a graph, and I had to label the vertex. So the vertex, you start at -1, -1, 2, so I went left 1, up 2, that's my vertex. And then I did a slope, because it's absolute value, it's linear, it's half of a linear function. You're going down 3, left 1. Okay, so number 6, we're doing more of this. Graph each function and label the x-intercepts, the y-intercept, and the vertex. So what I did for this is I started at the vertex, which was -4, 1, and I made a dot. Then my slope was a number in front of here was 1, so I went up 1, right 1, up 1, right 1, or up 1, left 1, up 1, left 1. And then if I extended this part of the absolute value, it crosses at 5, the y-axis. So this is my y-intercept. So the y-intercept I wrote as an ordered pair, 0, 5. My x-intercept is where the function crosses the x-axis. So you can see that it doesn't cross the x-axis. I'm also going to list the domain. So domain is all real numbers because this extends infinitely to the left and infinitely to the right. And I could also write it in set notation. So it's x such that x is between -8 and negative infinity and infinity. And then the range is what are all the y values that we can have? Well, there's nothing down here that's in our function, and our function doesn't start on the y until 1, and it includes 1. So this is inequality notation. I could also write it in interval notation. So this is 1 to infinity. I could also write it in set notation, y such that y greater than or equal to 1. Okay, then the second one. This is, again, absolute value, so we know it's going to make a V. It's reflected across the x-axis because this is a negative. And then the vertex is +1, -2. So I'm going to label that. The vertex is +1, -2. And then it's opening down, and the slope is 1. The domain is all real numbers. Again, the range is y is less than or equal to -2. I could also write in interval notation. I'm starting down here at negative infinity. So I'm going to make that a bracket. Negative infinity, I'm going all the way to -2 and including -2. X and y intercepts. There are no x-intercepts again, so this function is not crossing the x-axis. The y-intercept is 0, -3, and I wrote it as an ordered pair. Third one, what's going on with this one, the translation is you're not shifting anywhere in the x direction, and you're shifting down 4. So the vertex is at 0, -4, write it as an ordered pair. Where the slope, has a vertical stretch of 2, so I went up 2, right 1, up 2, right 1, up 2, right 1. And the x-intercepts are at 2, 0, -2, 0. And the range is domain is all real numbers, and the range is y is greater than or equal to -4. It's starting at -4 and going all the way up. And again, you can write it in interval notation as -4 to infinity. You could also write it in set notation. Like this. Okay. And over here, just describe each transformation. So just remember transformations, you can have stretches, shrinks, reflections, translation. And then I stuck in just another review of the vertex. So you can see that this first one, left 1, down 4. So the vertex is at -1, -4. We're not reflecting over the x-axis because this value in front of here is positive. but we are shrinking by a factor of 1/2. So that means for every 1 you go up, you go across 2. So it's wider. And then down here, we're translating right 1, up 3. So the vertex is 1, 3. And we're reflecting it across the x-axis because this value is negative, and we're stretching it by a factor of 2. And the last one, we're going up 8, and then we're not going left or right, so it's 0. There's not a reflection because this is a positive number, and there's not a stretch or shrink because the value in front of here is 1, which is our generic parent function.